Thank you. Okay, so a unit rate. If we talk about just the rate, a rate is a ratio that compares two quantities with different units. So I most oftenly think of like a cost per pound. Lots of fruit and vegetables you have to buy per pound. Okay? So like grapes, they sell them per pound. It's not like per amount of grape. You're not like, can I buy a bunch with 100 grapes on it? You buy 5 pounds of grapes, or 2 pounds of grapes, or 10 pounds if you have a big family. Okay? So it's two different units. They can't be made the same. I can't make grapes turn into money.
Yeah.
Does that make sense?
Yeah.
Great. So the unit rate is the unit of 1. And I'm writing unit because it's not always going to be like price, even though my example was talking about like the price per pound. So it's that unit, but it's just one of them. Okay? So that's the unit rate is when, so they're going to give you scenarios where you have two different units with big numbers, and they're going to ask you to find out what the unit rate is, which means what is it for one of those. So you're reducing or dividing what they've given you. Okay? Let's take a look at what that might look like. Okay? Find the unit rate for 210 heartbeats in 3 minutes. So we have 210 in 3 minutes. Jack, what do we do?
We divide
By?
3.
Yeah, 3 goes into both those numbers. And so what do we get?
You get 70.
70, but we have to make that make sense. 70 what?
70 heartbeats per minute.
Beats per minute. Per minute. This is the unit rate. Okay, so we weren't talking money, but we were talking per minute. Does this make sense?
Yeah.
So far, so good, right? Great. Let's do one with money. Using it to compare. Sometimes people ask me, when am I going to use this? Right? That's like a famous math question. When am I going to use this? Why do I need to know this? And honestly, when I was your age, I didn't know what I wanted to be. I thought maybe an orthodontist because crooked teeth bothered me when I was in 7th and 8th grade. Obviously, didn't see that one through. So I didn't know I was going to be using this math every single day when I was in 7th grade, but now I actually do because I teach it. But there's a lot of jobs when you grow up where you use a lot of math. My husband, he is in construction. He runs job sites. I bought him an app that was like for fractions, right? Because when you're measuring things and you want the center, you cut your fractions in half. You have to, anyways. He says it's slower than him just doing it himself. Like a fraction calculator is slower because he's that good with his fractions. I mean, that's impressive, right? Again, tons of different things you might use. But this, everybody will use. Peter, tell me why.
Like, I think we learned this last year with Mr. Howard, if you're in the grocery store, you need to figure out which is the better buy. Yeah.
No matter what you become when you grow up, my prayer for you is that you're not wasteful with your money, right? No matter what you are, whether you make a ton of money and it doesn't really matter, or maybe you make just enough and so you have to be smart with it. I hope that you just don't waste, right, in all the things that you do. But this is an amazing tool because does it make sense to go to Costco and buy the huge amount of whatever it is? Or maybe check the sale at CVS because sometimes that's a better price per unit. Yes?
Yeah, so like we learned this thing to figure out how, like, if you're getting like a big pack of something, like you see how much it costs for like one, like whatever you're getting.
Uh-huh. So that's what we need to do is we need to find the price per one and then we compare those numbers. So this is example 3. I'm going to put a 3 here because it's example 3 from the book if you want to go back and take a look. And it's talking about shampoo bottles. Like, which is better? Should we get the huge Costco brand shampoo or do we want whatever, something from Target? So the first one is $3.99 for 13 fluid ounces. And the second one is $6.19 for 16 fluid ounces. So we need to find the unit rate, the cost per one. So that means we have to divide. When we divide with money, where does the money go? Inside or outside? Money always goes inside. Always, 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 always. Put the money inside. It's what we're dividing, right? That's what's getting smaller. We're not dividing the shampoo bottle. We're not taking out fluid ounces. We're taking out money, okay? So $3.99 is going to go inside, and on the outside we have 13.5. Can we start this problem? What do we need to do first? Yeah, we can't have a decimal on the outside. So if we move it once on the outside, we need to move it once on the inside. I like to keep things clean, so I'm going to rewrite it. 135 into 39.9, and I'm going to bring up my decimal. Okay. 135 into almost 400. How many times is it going to go? Does anybody have a guess? What should we start with? Gianna? 2 maybe. Okay, so 135 plus 135. I always like to show my work. 270. Can we get closer than 270? Maybe. I don't know. So 135 times 3. Let's try it. 5. Carry the 1. 0. Did I do that wrong? 15. 9. 10. Carry the 1. 4. 405. That's too big, right? It's close. It's so close, but too big. So we're going to have to do 2. So 0.2. Do some basic math here. I end up with 129 left over. What do I do with that? Got to bring that 0 down. Some old school long division. Now what? This is a much bigger number, right? I know that 135 times 10 is 135 with a 0 on the end. So what number should I try? What makes sense, number sense to try? Harry? 8 or 9. I'm going to go big. I'm going to go 9. So 135 times 9. What do we get? 1,215? Great. Is that going to work?
Yeah.
So it's 9, 1,215. When I subtract What do you get? 75. This is going to keep going. If we're talking money, how many do we need? Show me on your fingers. 2, which means we need to go 3 spaces to make sure that we are confident in our 2 numbers. Does that make sense?
Yeah.
So we're just going to go one more time. Dom, where are you?
I just have a question.
Sure.
39.9, then you minus, wait. Why would there be like an 8? Isn't it a 9?
It was a 9, but I borrowed to make this a 10, so I turned it into an 8.
Yeah.
I just didn't write it above and little. Does that make sense?
Yes.
Okay. Okay, so here we are, 750. We need a good guess. We need a good guess. So we know that times 2 is 270, times 3 is 405, and times 9, that's what we know. Peter?
I think 5.
5. So 135 times 5. 675. I think that's as close as we're going to get, right? Because 135 more is going to be too much. So 5 it is. I don't even have to continue. I don't need to write it and subtract, right? Because I just need my 3 numbers up here. What is the 5 telling the 9? Go up. What does the 9 then tell the 2? To go up, right? So for this answer, for our first bottle of shampoo, I'm going to put it on the left side because I sort of used all that space. I get approximately, I'm going to use a wiggle line, 30 cents. I'm going to use this squiggly because I rounded it, just to remind myself that I rounded it. Okay? Now we get to check the next one. A lot of math, but it's easy, right? Long division, it's like, okay. Money goes inside, so I have 6.19. Fluid ounces is going outside, I have 16. 16 is an easier number to work with. Does anybody have a guess? How many times is 16 going to go into 61? Milo? What'd you say? 3. 3? Okay. 16 times 3. 48. Is that the closest? Okay, I'm going to bring up my decimal. 0.3. Put in 48 and subtract. I get 129. 139. Is that what you guys got? So now I have to do 16 into 139. So I know 16 times 10 is 160. So I'm thinking bigger numbers, right? I don't want to mess with like 4 and 5. Those aren't good guesses. Lucas, what's your guess? Times 7. 111. Can we get closer? We're 112. Sorry, 112. 16 times 8. Let's see, 48. Carry the 4. 128. Can we get closer?
No.
Yeah, it'll be too much, right? So we've got 8. And do we need to continue for this problem? Tell me why. Because I don't have 3 numbers yet, Nora.
You already know that the first one is approximately 30 cents, even less than that. So, because it can already 0.38, you know that it's going to be more.
Right? So you guys are going to use your brain, right? And use your time wisely. Even though I should get a 3rd number in order to accurately give me a good number, a good cost value for this unit rate, I don't need it to answer this problem because the question is which one was the better buy. And 30 is much smaller than, it could end up being 39. Maybe it's going to stay 38. I don't know, right? But 30 is cheaper, 30 cents per fluid ounce. Okay, I'm going to circle this and I'm going to write better buy. Are you guys ready to try one like this on your whiteboards?
Yeah.
Okay, great.